Welcome to the Frontend tools of the past, today, and tomorrow. And it's going to be a small history lesson, and then we'll go into what's currently up there, what's the hot stuff, and then it will just dive into pure speculation of what's ahead of us. It's just, pure fantasy, right? My name is Mikhail, and I work as a developer experience engineer in a company called TopTal. The timer is not running. Can someone start that? Thank you. And I think the legal team is calling me and asking me to say that everything I say in this talk is of my own and only my own opinion, does not represent the opinion of the company. Thank you. Now we can go. Anyway, I am cursed. For many years, whatever team I join, it's always something I end up in the framework internals, digging into Webpack configs or whatever else. Over the years, I just embraced that now. It's my official title. That's what I do now. And let's go all the way to the beginning, not this far. The prehistory. Let's call it like this. The era of the Web 1.0. It was as beautiful as it was pure. We had HTML. That's it. It was amazing until, let's say, 1994, 1995. This guy comes out and some people in Netscape Navigator team ask him, hey, can you make a language that will enhance the experience and add a little bit of interactivity? And by the way, you have 1 week. He's like, OK. Then fast forward quite a few years, and Internet Explorer is now dominating the browser space. It's early 2000s, 2004, 5, something like that. And we got the Web 2.0, the era of user-generated content. Websites are now, every single logotype is shiny. Everything is interactive. We got Ajax, we got jQuery. That is where the browser war starts, if you remember that, and that's when jQuery comes to save the day. Websites can now display things coming from the server without reloading the page. And fast forward quite a few years, we naturally come, as in any historical period, we come to the Renaissance. And if you asked me in, let's say, 2014, 15, or something like that, oh, Mikhail, how hard it is to get into front-end development? What should I know? It's like, yeah, it's easy. We got quite a few preprocessors better that, all of those Sass-less stylists. We got CSS and JS, CSS models came out. Well, no one really writes JavaScript. You got CoffeeScript. There's Flow. We got also TypeScript, RevScript. That's some stuff that came out. Oh, by the way, you need to run this all somehow. And there's some bundling involved. And yeah, by the way, code quality is really important. And you got to test this. All of this stuff, it is insane. There's just so much stuff. And the best part is it all runs on your very hot, miserable, slow computer. If you remember that experience, maybe you got to experience that somehow. We got shipped the amount of code that we shipped exponentially, it grows exponentially. JavaScript developers like to create and create and create more and more code over time, right? And if it's not running on your computer, it runs in the cloud, and someone else got to pay for that. It's someone else's computer. Let's take a look at, let's say, a typical 2020-ish front-end release pipeline. It all starts with the code changes, which are, let's say, git commit. We got to perform type checks, generate definitions. Assuming, we are good developers, we use TypeScript. Then we transform that to target output and bundle things. Then we can run bundle relent tests. And right after that, if all checks are green, no, wait, we also got to transform tests code to target output, which is TypeScript tests, JavaScript runs, then the run tests. If everything is good, code quality is good, we deliver it to CDN. Right? This is a real-life example of an app around 1 million lines of code. It's a big JavaScript app, massive monorepo, and I worked on it in 2021. And we had, for type checks, we had 3.5 minutes of TypeScript, just running, checking types, transforming, bundling 6.5 minutes, tests 4 minutes, running tests 45 minutes, which is insane, and the code quality just the ESLint preacher running on this massive beast would take up to 15 minutes. And the bundle relent tests would be around 1 hour, but that's whole user flows and stuff like that, end-to-end tests, so to say. Yeah, this is the real thing I worked at. And now, we come to the modern history. This is where we are right now. The most exciting times are ahead of us, or right now. And all of those tools were written by JavaScript developers for JavaScript developers. And naturally, they were written in JavaScript. And it's not a bad language, and those are not bad engineers. The progress is standing on the shoulder of giants, but with the millions and millions of lines of code we have, the JavaScript just does not scale up that much. It does, but yeah, it gets slow. So we just decided, yeah, what if we, wrote the same tools in something that's faster? It compiles to native languages. And this is this is a division of tools that I made up in my head. It's not something you find on the internet, hopefully. So we got the foundational tools. This is where you find stuff like Babel, TypeScript itself, maybe ESLint. This is tools that are usually a part of a larger pipeline. And at the top, we have stuff like Webpack, Rollup, and other tools like that just call them sequentially. Test run, there's maybe like Bowel, Gulp, if you remember that. Same stuff. Right, let's talk about the foundational tools of the new era. And we'll start with the two big brothers that I think were born, out of sheer boredom of the two of them respective authors during the COVID lockdown. Like, you lock a absolutely cracked engineer for several months in a room and they will create something insane, right? Roughly appeared at the same time, and we'll quickly get over those. So the SVC or SWC is a speedy web compiler. It's a really interesting name. Written in Rust by Dong-Yoon Kang. It is fast, it can bundle with some limitations, and can minify. And it's more something I would call it's open to feedback and community focused, right? Like you, as a community, you decide where the tool goes next, accepts PRs and stuff like that. And ESBuild, on the other hand, is ECMAScript Builder. It's written in Go by Evan Wallace. It is fast, it can bundle with some limitations, it can minify as well, and it's more for a single-person centric in the sense that, oh, I am the guy who wrote this. If you don't like how it works, well, good luck. That's for me. Now, those benchmarks are from 2021. These are highly irrelevant, but are just here for the scale to see how fast both of those things are compared to something like TypeScript or Babel. That is for a relatively big React code base, so you add JSX, transpile stuff, all this stuff like that. Right. So this is also a slide from 2021 when I gave this talk for the first time. And these were the problems between both of those things. So it's really hard to find community support. This just came out. It's an alien technology. It can't handle everything. You cannot do bundling with that. You still have to resort to old, trusty, reliable tools. And the benefits of adoption, yeah, you have to change some code, especially if you're using ESBuild. Right, now I would say only one of those points is still true, which is, yeah, code bundling is still not a reliable thing in either of those tools. Right, let's move on. Oh, yeah, let's plug in. So we used to have Webpack in our build pipeline, and we plugged SWC into the transforming part. We got down from 6.5 minutes to just 2 minutes, which is over 3 times the drop in time, which is insane. And of course, the test code, because it does not require bundling, it is now 3 seconds instead of 4 minutes. Great. Now, on to the next thing. Lightning CSS. The creators of Parcel didn't sleep on the evolution and decided, oh yeah, what if we write a modern CSS processor, and that handles CSS modules, Sass, less, whatever you want. And that is also written in Rust, and it is used in tools like Tailwind CSS currently, and I think it's not old Next.js logo. I hope Vercel will not sue me. Right. Now, finally, onto the oxidation compiler, which is, let's just say for now, it's a really, really fast linter. And it is approximately 50 times faster than ESLint, as reported by some of the benchmarks here. But we'll come back to this later. Remember it. Right. Let's now talk about the conventional tools of the new era. And starting with, of course, everyone's favorite, Vite. I almost said Vite, and it's really hard for me to not say Vite, but it is from French, I think. Is it true? Yep, it is from French. So yes, Vite. It is, okay, it's too early. Probably anyone else here familiar with Vite? Anyone uses Vite? Okay, well, much less people than I expected, but you know, the biggest kind of selling point and the magic itself is the bundling system. So in traditional, let's say, in something like Webpack, you would type npm start, pnpm start, and you would get this long bundling process of the module crawler going through your imports and stuff like that, and bundling it all in one of several JavaScript files. Then your development server is ready. However, with Vite, what you would get is when you request an entry point, only the stuff that's actually required is delivered to your browser in the form of ES modules, which is a thing that is now supported in the browser. And everything else is not loaded. But you say, like, whoa, what about my nude modules? But you somehow gotta handle that, right? And the nude modules are handled by ESBuild. Before you start the server, it usually runs once, and then you're good to go. Right, so it is still using a traditional and battle-tested JavaScript bundle. So under the hood, if you run in production, Vite will call rollup. And in development, you get the ultimate developer experience, right? This is a small comparison between, like as I was talking, Vite is already done and Webpack is still, going. It's exactly the same app, we just replaced it. That was also just when the Vite just came out, so it's maybe even better now. Who knows? Now, for the big thing, anyone here uses Webpack in their pipeline something? Okay, well, everyone else is using something or not. I don't understand. Right, anyway, this just came out. I mean, it came out of a long development cycle, but this is called RSPack, and that is designed to be a drop-in Webpack replacement. So you just replace your Webpack with RSPack. Most of the time, stuff will work out of the box. And it is marginally faster, which is incredible. It's a whole set of tools. You get RSPack, you get bundle analyzer, separate bundler for libraries, UI libraries and frameworks and stuff like this. It is incredible. Let's plug it into our pipeline. So we got down from, originally it was 4 minutes, which is the SVC. It got down to 20 seconds with RSPack. And everything else is, well, pretty good. It was starting to look pretty good now. Now, Parcel, another, let's say, conventional tool of the era. And you might ask, well, Parcel is old, why is it here? And that's just because Parcel has embraced the philosophy which has always been like, you just open it up and it works out of the box. That's how it works. And now they just plugged in SWC and developed Lightning and CSS, so now it's fast. It's still slower than other tools like Webpack or RSPack or Vite, but if you have a small project, that's probably what you're looking for. Now, here's the fun part. This is Rolldown, developed in Rust. It is really early in development so far, and it is designed to be almost rollup compatible, and it's built with the oxidation compiler, the tool that I mentioned earlier, you remember, is a really fast linter. We'll be back to it again. And this is the dream that Vercel wants to sell you. I will pitch it, but I'll not sell it to you. This is the Turbo Pack. And that is, I will just briefly talk about this. There's a lot of stuff to take in, but most of the time, the thing is, the killer feature is just simply memoizing the functions and memoizing the bundle out. I'm sorry. Memoizing the bundle output on the function level, and then you get to do less work. It's much faster. It's also, I think, written in Rust. But yeah, you can go to the website if you see. And now you can only do that with Next.js, of course. Right. I don't know why this picture is here. Let's now talk about the biome. The biome was originally designed to be a bundler, compiler, documentation generator, formatter, linter, minificator, tester, test runner, type checker, and much more. But now it's a code formatter. Let's see. This is the dream. This is the dream I'm ready to sell to you, because this is something, the original idea of then Rome, now Biome is incredible. So let's say we have a couple of tools we want to run in our pipeline. We have stuff like TypeScript, and we need to get rid of the JSX, then we need to run Treater and ESLint, then we need to run something like Cursor to minimize, and Webpack to just do the modular bundling. And let's say all of those tools do something, right? So the first step for any of the tools is parse code and build an abstract syntax tree, which is then used to do certain calculations and produce a result. Anyone sees something that could be improved here? Of course. This is done at least 6 times every time you do something. If you run your pipeline, this exact step, every single tool repeats themselves, right? But if one tool can do it all, we could save on so much work. And that was the selling point of it. Unfortunately, over time, yeah, it's still just a code formatter. Their team let's get something scandalous, but I don't quite remember that. But team is still working on it hard. It's going much slower than expected now, but it works as a code formatter. It is pretty fast. And if we replace our 15 minutes in our pipeline, got down to 10 seconds. And this is looking really good now, and this is what you can do it right now already. So why do people still live like we're in the Renaissance era? You already have all these magical tools, and you just waste your time. So we got down from 25.5 minutes to 33 seconds, and that adds up to being roughly 46 times faster, 30 times per day. This is, I calculated as average pipeline runs, 750 minutes per day, 375 hours per month, and 4,500 per year. This is how much you can save on CI. But it's not expensive. It's just 2,000 years on the standard size GitHub run. It's nothing for a business, but the developer time and sanity is priceless. And this is where you save up the most. Anyway, as I just talked about the biome dream actually lives on in the future. And this is something that's coming in the future, hopefully. We don't have the timeline. This is just rumors I heard and asked a guy on Twitter, and he told me in secret. So the Vite, the roll down is developed by the Vite team. And this is aiming to replace both rollup and ES-build in the future. Which means that everything will be powered by the super fast bundler. And this, in turn, OK, let me just draw the schematics here. So OXC compiler, I'm hoping I'm not going to sound like an insane person, is AST parser, and I didn't finish writing that, sorry. I have no hands. It is transformer, it is a resolver, minifier, and that, in turn, powers roll down. Then the roll down is going to be powering Vite, and the Vite is going to get rid of that. And also, since we have the same AST, formatter and linter can be also handled by Vite in the future, and that's how we almost achieve the dream of biome, which is incredible. Right. That's all rumors, of course. Don't quote me on that. Let's talk about the future. In the future, in the very bright future, yes. So why do we even bundle? Why do we build and bundle code? Why can we just not write JavaScript as like a good old JavaScript as we did before? And the question comes that the browsers do not understand the code we want to write. Browsers don't understand TypeScript, they don't understand JSX, and a lot of other things. And the network overhead is the thing, because it's a hard thing to just grab over a bunch of ES modules, and we'll talk about this later. And cache invalidation is really hard. If you just have no hashing in your file names, that's asking for trouble. Right. Maybe we got solutions for all of that in the future technologies. And first of all, starting with import maps. So this is something that is already available right now, and you can use that to run the dream of no-build code, right? So for those who don't know, import maps this is something you can write and ship straight up to your browser with an extension. And here you basically tell the browser, OK, if you import from left pad, this is actually importing from this file. And this can be used to add hashes. So you can selectively invalidate one file in the browser without bundling, which is incredible. And there are already some people preaching this. You can probably already leave the no-build dream if you use Ruby on Rails, for example. Right, but there's still things like network overhead, because this is a really big problem coming back from HTTP 1 days, I will say. So in HTTP 1, we could only request one thing at a time per one connection, per one TCP connection. And HTTP 2 solved this problem by introducing things like streaming. You can request multiple files in a single connection. But the problem still persists that because it's TCP, and TCP is, oh no, I'm only doing the right thing. I'm always asking, like, is the file good? Is the packets are good? And always doubting myself. So if something breaks in here, if we get a connection drop, we gotta wait on it. We gotta re-request it. It's a whole other story. It's called head of the line blocking, I think. I'm not an expert on this, but just saying. And in the future, there is something used to be called Quick, which was developed by Google, and now it's HTTP3. This is built directly on UDP, and it does not have the same limitations as TCP has. And the congression control and loss recovery is handled by the protocol itself, which simply means that for us, we can, let's say you are loading a website and you walk into your house and you get connected to a Wi-Fi. And the website will continue to be loaded, and there will be no network interruption, which is incredible. And also, there's much less overhead on loading a lot of files at the same time, which you can, in theory, bring us closer to the dream. Right. Well, TypeScript. TypeScript is a beast. If you anyone ever looked at inside the TypeScript code base? No? Okay, I feel sorry for you. But it is really scary. And a couple of brave souls actually attempted, so this is the creator of SVC, Dong-Yun Kang. And he actually, back then with Rome, he was trying to collaborate on people actually rewriting the TypeScript in a faster language. But after that, I don't think he ever continued that, because this is, frankly, even for talented people, it's insanity to rewrite that. And this is just a question of time and the complexity of code. I also asked Boshan, this is a person working on the oxidation compiler, if he ever tried to implement that. And frankly, it's a problem of funding. It's not just a technical problem. Most people working on those are open source enthusiasts, so to say, and talented engineers. They just need money. If you're working in a rich company, please sponsor that. Right. Now, this is also more from a pure fantasy perspective. And this is a proposal, the fourth most starred proposal in the history of TC39, which will bring type annotations that will be just, so you write thing that is almost like TypeScript, but not quite that, and it will run directly in the browser. It is stage one, it's years to be implemented or not implemented, maybe it will be rejected. It is really controversial and contested, because when you get a lot of smart people in TC39, they can never agree on anything. So this is pure fantasy, but who knows? Who knows what's going to happen? Maybe this is the future of our pipeline. There will be no build. There will be instant linting. It will be incredible. Everyone will be happy. And most importantly, do not forget that even though we have all these fancy tools, do not just say, oh no, like I no longer need Babel. Babel is no longer needed. It's obsolete. We no longer need post-CSS. Please support the creators. They are doing a fantastic job, and frankly, this is going to be needed for many years to come. And with that in mind, I thank you for your time. And if you scan this QR code, you want to contact me, it's my really silly website. Thank you.